Assalamualaikum and selamat sejahtera. Today I want to present our research title Evaluation of Modulus of Elasticity of Local Hardwood Timber. This research was done by Nomah binti Jainuddin and I am Muhammad Azmi bin Nadi. For the introduction of this research, as we know that hardwood timber has been used thousands years ago as a structural member in the construction industry. The use of hardwood timber as an engineering material in building construction is decreasing year by year and being replaced by metal material. Even though metal material replace hardwood in building construction, we still cannot disregard the importance of hardwood in some building construction, especially in a traditional wooden house. One of hardwood timber that very popular in Sarawak is Eucalyptus roxylon zwagiri, or known as Belian hardwood in Malaysia, Ulin in Indonesia, and Borneo ironwood in English. As reported by Sonagara and Lehman 1993 and United States Department of Agriculture 2010, this evergreen tree species is distributed in eastern and southern Sumatra, Bangka, Belitung, Borneo, and the Sulu Archipelago and Palawan. Even though this tree grows very slowly, but Belian hardwood is the heaviest timber and most durable timber in Southeast Asia. Due to this nature, Belian hardwood is commonly utilized for marine work, boat building, heavy construction, and roof shingle. Borneo Tops 2020 state that the people of Sarawak and Sabah use Belian hardwood for building and structure as well as for their art piece like masks or effigies like Kenyalang hornbill bird in Sarawak, which is symbolic of Iban God. These pictures show that one of the example using of the Belian hardwood to build belawing Perbeka Tawai or United Heart Pillar that located in Sungai Koyan Asap, Belaga, Sarawak. This 24-meter tower is the tallest belawing tower recorded by Malaysia Book of Record. Is a landmark that unites the Orang Ulu around of this area. Besides that, Belian hardwood are frequently utilized as the basic framework of wooden homes such as beam, column, and joists. However, as the construction requires stronger material such as reinforced concrete in maintaining the building structure, the use of timber is a deterrent. Abdul Latif et al. 2019 state that the deterrent factor for the use of timber product in building construction in Malaysia were high cost, poor durability, restrictive building cost, and low fire resistance. Record 2004 state that the mechanical properties of wood are its fitness and ability to resist applied or external force. Examples of mechanical properties of wood are stiffness and elasticity, tensile strength, compressive strength, shearing strength, bending strength, toughness, hardness, capability, and resilience. In engineering study, mechanical properties that must be determined before the material are decided to be a structural member of the building is a modulus of elasticity. The modulus of elasticity is very important to identify in order to predict the behavior of material when subject to a force. The Malaysia Standard Part 2 2001 indicated that an average modulus of elasticity for Belian hardwood is between 12,000 mm to 18,000 mm by considering its moisture content much greater than 19%. Therefore, this study is done to determine the moisture content and to evaluate the elasticity modulus of Belian hardwood by performing an experiment in structural laboratory. To achieve the objective of this study, two test methods were performed such as to obtain modulus of elasticity and moisture content of Belian hardwood. These tests were all carried out at the Structure Laboratory of Polytechnic Kuching, Sarawak. Usually, there are several methods to obtain young modulus. According to Mariko Yamasaki and Yasutoshi Sasaki in 2010, in their research determining young modulus of timber on the basis of strength database and stress wave propagation velocity, the method of obtaining young modulus is 1. Load method, 2. Frequency analysis or impact method, 3. Ultrasonic method, 4. Stress wave method. Among these, the load method requires to specify the cross-sectional shape of the material, which is very suitable and simple method that can be used in structural laboratory. For this study, the modulus of elasticity was obtained by performing a deflection test method. The deflection of a beam is calculated based on a variety of factors including material, the moment of inertia of section, the force or load applied, and the distance from support. Figure 1 and Table 1 shows sample and size measurement that used in deflection of cantilever beam experiment. In this research, 7 samples of brilliant hardwood are used that have the same length but different width and depth as shown in table number 1. To perform this study, the main apparatus used to find modulus young of brilliant hardwood is STR4 apparatus for deflection of beam and cantilever, and also oven dryer are used to find moisture content of brilliant hardwood. This slide shows the standard procedure for deflection of cantilever beam experiment that was used in this research. The arrangement of apparatus is shown in Figure 2. As for the methods supplied with the equipment gave maximum flexibility and easy of use, and the mass applied on this experiment was increasing from 100 gram to 500 gram. The modulus of elasticity calculated as WL power 3 over 3 times Y, where W is load, L is length of beam at load position, and Y is deflection of beam. As for the moisture content of hardwood specimen, it was obtained by oven drying method. Moisture content was determined from the same piece of hardwood sample with the size of 20 mm x 50 mm and 10 mm thick as shown in Figure 3. So Figure 3 shows the sample of wood specimen that have been oven dried after 24 hours. To carry out this experiment, the wood sample material must be weighed before being placed in the oven and then placed in the oven at 1103 degrees Celsius for exactly 24 hours. The moisture content is calculated in percentage weight at green condition minus oven dry condition over oven dry condition times 100%. For result and discussion, Table 2 and Figure 5 show the result of average value modulus of elasticity for brilliant hardwood. The result of elasticity modulus obtained were not significantly different among samples. It was thus obtained that the young modulus of brilliant were achieved with the result range between 12,000 Newton per millimeter square to 80,000 Newton per millimeter square for wet or green condition, where this grade stress of timber governed by Malaysia Standard Part 2 2001. These results were not significantly different with the study of Isos Nada et al. In 2020, where they obtained the value of young modulus is ranged between 15,880 Newton per millimeter square to 20,630 Newton per millimeter square. Based on Figure 5, the minimum value of young modulus was 12,568.58 Newton per millimeter square from sample 2, and maximum value of Young modulus was 18,804.74 Newton per millimeter square from sample 4. The result of modulus of electricity might be different for each sample because the measurement of each sample is not same. Table 3 show mean value of moisture content were 29.37% and Young modulus of Brian Hardwood is 15,529.57 Newton per millimeter square. Figure 4 show the moisture content for each sample were measured at the wet condition. It shows the minimum value of moisture content was sample 1 with 24.44% and maximum value of moisture content was sample 2 with 37.35%. The moisture content for each sample is greater than 90%. That proves that the sample of Brian Hardwood applied on this study is categorized as the strength of timber indicated in Code of Practice Malaysia Standard Part 2 2001. For the conclusion, the the study aimed to evaluate the mechanical properties of elasticity modulus of local hardwood timber, which is Bolian hardwood. The following results were obtained. 1. The result of Young modulus obtained by using the deflection test method were in range 12,000 to 18,000 Newton per millimeter square, where these values are categorized as standard elasticity modulus of Bolian hardwood that published in Malaysia Standard with Code of Practice Part 2 2001. Number 2, all the moisture content results from beam sample were greater than 19%. That proves that the sample of Bolian hardwood applied on the study is categorized as a strength group of timber that is indicated in Code of Practice Malaysia Standard Part 2 2001. Meanwhile, the STR4 apparatus in Structure Laboratory in Polytechnic Kuching Sarawak is reliable for checking and determine the modulus of elasticity of other type of wood categories. For the recommendation, number 1, for further study, it is really recommended to conduct the experiment of deflection test with a various sample of beam material by using STR4 apparatus. By using a deflection method to determine the Young modulus of material, some expensive apparatus are not necessary, and moreover, the tests are relatively simple. Number 2, furthermore, the deflection test also can be carried out with simply supported beam by follow the procedure given in STR4 laboratory manual sheet. By conducting such experiment, more result and finding can be elaborate. So number 3, in the course DCC 40172 Structure, Hydraulic and Wastewater Laboratory, there is an experiment of deflection of cantilever and simply supported beam. So through this experiment, students were able to conduct a test of a beam deflection to determine the deflection of beam. Therefore, by conducting this same experiment, students not only can obtain the deflection result, but also they can able to obtain the value of Young modulus. Thank you for today and Assalamualaikum.